Okay, this is lesson 13.3, the very last lesson that we're going to cover out of this textbook. Yippee! Volumes of spheres. If I really had it all together, then I would have some kind of like end of the year music or whatever. Okay, volumes of spheres. And I kind of want you to pay attention to this picture here a little bit. I know sometimes you're like, whatever. This, I'm going to show you here in just a second what I'm trying to do. I'm trying to make the picture do this with Play-Doh. Well, yeah, you can imagine how it's going to turn out. All right, so we're going to work on the formula for the volume of a sphere. And so here I have my handy-dandy Play-Doh, and it's in the shape of a sphere to the best of my abilities at this point. So, yay! And here I go. I'm going to start doing all these little cuts. I'm going to cut this in half, and then I'm going to cut it the other way in half, and go on and go on and go on. Now, since you don't want to watch me cut and keep cutting, I already have one cut for you. It's kind of like one of those cooking shows where they have stuff pre-cooked. All right? And you can kind of see there's lots of different pieces, and I'm going to take this apart, and if I cut it up into the lots of these little different pieces, and I could cut it up even smaller if I wanted, I'm going to get pieces that look like this. Okay? And this is roughly a square pyramid. And look at this. This is roughly a square, because the base is a square, pyramid. Cool. This is very roughly, not quite a square there, but it's definitely a pyramid. Okay? And it's actually not going to matter too much in the end. But these are all supposed to be little pieces of square pyramids that are coming out. Okay? Whether or not they actually look like that, if I could do that perfectly. All right, so let's think about a square pyramid. Isn't the formula for that, for the volume, isn't that 1/3 the base, the area of the base times the height? And it just depends on if we have a square or a triangle, and it really doesn't matter. So we're going to have 1/3 base times height for this piece. And I'm going to add in 1/3 base times height for this piece. And I'm going to add in 1/3 base times height for this piece. And keep going and going and going. Dot, 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 forever and ever. All right, until all of my pieces are taken care of. But if I cut them into smaller pieces, then I'd have even more pieces. But let's go ahead and do this. Every one of these has a 1/3 and an H. Okay? I'm going to pull that out. You're like, why am I pulling that? Because I actually kind of know where I'm going, so just kind of follow along. This leaves me with all my bases. Like base 1 for this piece, the base of this piece, the base of this piece. So I have all these different bases. Okay? All right, now, what's the height? If you think about it, the way I pull this apart, go back to this, what is the height of the piece? Okay? If I keep cutting that half, and then I keep cutting it in half again, and I keep doing that, the height is actually the radius of my sphere. Okay, so if I were to cut this down and keep cutting again and again and again, see, this is still the height. If I were to cut this again into my other piece, as I'm going apart here, once again, trying not to show you way too much of the cutting, but yeah, whoops, but the idea is, you're going to have to trust me, the height is your radius. So I've got 1/3 the radius plus all these bases. But let's think about these bases. It doesn't matter if it's a triangle or if it's square. If I put them all together, there's the base, there's the base, there's the base. If I put them all together and I have all these bases together and together and together, and I just keep putting them all together, don't I get the surface area? Don't all these bases add together? It's the surface area of this. All those bases. Woohoo! Woohoo! Oh, that's so lovely. Hey, what's the formula for the surface area if I add all those bases? 4 pi r squared. That's from last chapter. Keep going. Let's see. 1/3. I have an r here and an r squared here. So I have 1/3 times 4 times pi times r cubed. And wait a minute, 1/3 times 4 is 4/3 pi r cubed. So your volume of a sphere, and this is what you should be writing down in your notes, is 4/3 pi r cubed. Yeah. And that's how they come about it. So it's not, I could just tell you that and the world would go on fine if you never knew how that came to be. But once again, it just kind of gives you a little depth, or if you get stuck, you can say, hey, I know what the formula is, and this is why the formula is what it is. Okay, so 4/3, and I'm trying to write from my computer, pi r cubed. All right, we're just going to keep going here with the example problems because I don't think it's going to take us very much to get through these. Find the volume of the sphere to the nearest tenth. So we're going to have 4/3. Oh, we're going to take a little moment here. 4/3 pi r cubed. The radius in this particular case is 15 centimeters. So it's simply, I'm going to put 15 in for the radius. So 4/3 pi, radius is 15, and we're going to cube that. Okay, once again, do a test run on your calculator to make sure that this is going to work right, okay? That you are able to do all the math in the correct order. I am getting a volume of 14,137 point, and this is round to the nearest tenth, 0.2. Our label will be centimeters cubed. Okay, that should be 4/3 pi r cubed. Okay, next example, example 2. Find the volume of the sphere to the nearest tenth. And they give us the circumference. Well, what do I need to find the volume? I need the radius. Okay, well, how do I get to the radius? Well, I gotta remember, C to C, write the D, there's always pi involved, or you can think 2 pi r. And I'm gonna use 2 pi r because it has an actual radius in it. So I'm going to have circumference equals 2 times pi times r. To solve for r, the fastest way is to divide by 2 pi. We've talked about this before. Make sure you're dividing 25, then put your parentheses, divided by, parenthesis, 2 pi. Otherwise, you will be getting the wrong answer over and over again. Okay, there are other ways to get to that. You just need to make sure that your way is getting you 3.9789. So now I rewrite that in my formula. Volume equals 4/3 pi, radius 3.9789 cubed. So I'm going to cube that number, because I have my calculator, times 4/3 pi, and I am getting 263.9, and my label should be centimeters cubed. Okay, make sure you can do that accurately on your calculator. Okay, third problem. Find the volume of the hemisphere. So I just have to take half of the volume of the sphere. So I've got 4/3 pi r cubed. I'm going to take half of that. HS is for hemisphere. So I'm going to take half of the 4/3 pi r cubed. Okay, my radius is not 6 feet. My radius is 3 feet. So I'm going to have 1/2 times 4/3 times pi times 3 cubed. Okay, and let's go ahead, go to your calculator and do all kinds of math. Double check with me that you've got the same thing. I'm getting 113 for the actual volume, and then I just divide that by 2. And I'm getting a volume of 56.5. And this should be feet cubed. Okay, hemisphere, the surface area is different because you have to talk about the surfaces, and then you cut it in half, you got another surface showing. But this is a volume, so you're just saying wherever the volume of the sphere is, if I just cut it in half like at Play-Doh, then you got half of it left. Okay? And actually, I'm going to go right to the end of this. All right? There was a little sneak of a problem there, but I decided to skip it on the video. So this ends lesson 13. It ends our last lesson of the chapter. It ends our last lesson of the entire book. And we will be working on our project after you have this done, after you take your chapter 13 test. Alrighty? Dighty.